Station, this is Houston. Are you ready for the event?
Houston, we are ready.
European Space Agency, this is Mission Control Houston. Please call station for a voice check.
Station, this is the ESA moderator, Alana Bartolini. How do you hear me?
I hear you 5 by 5. How do you hear me?
I hear you 5 by 5. How do you hear me?
Excellent. Thanks so much. Hello, Thomas. Good afternoon. You're now connected with Romania, Ireland, and Portugal. I'll hand over to you for some opening remarks, then we'll open the floor to questions.
All right. Hi, everybody. It's a pleasure to be with you today from the International Space Station. I like to watch Europe, the whole of Europe, everything together. So I'm happy that we have lots of different countries today, and I'm ready to answer all of your questions.
We will begin with our first two questions from Romania. Romania, please go ahead.
Hello, Tom. I'm Ovidiu from Gimbolia. When we think of space, most people think of exploration. What are some other activities related to space that society may not be as aware of? Merci.
That's a good question. There's a lot of activities that we do in space that people might not be aware of. There's Earth observation. We monitor climate change from space. We can provide environmental disasters relief and support. We do navigation from space. GPS, Galileo are good examples. We do telecommunications from space, space applications, TV, mobile communications, you name it. We also do a lot of science. We do research here on the International Space Station, but we also have dedicated satellites that study the Earth, that study the universe around us, probes that go all over. So that's a lot of various activities, and human spaceflight and the ISS is just one of them. But they all make sense together in a coordinated effort to understand better our world and put space at the service of the Earth.
Hi Thomas, I'm Valentina Matei from Dacia School Oradea. My question is, what kind of research are you conducting during the Proxima mission that could contribute to new technologies to be used in our daily life? Thank you.
That's a good question. We have lots of technology demonstrations. Maybe one of them is called Matisse. It tests new surfaces that prevents the proliferation of bacteria. It's going to be very helpful for us on the ISS, but it could also be used on the ground in hospitals, in a clinical environment, or in transportation hubs like airports, the underground, things like this. We have Aquapad. It's a new way of testing water for coliform bacteria and microbial life. It's much faster than we used to do before, and it could be used in countries where access to clean water is sometimes problematic. So that's only two of the examples, but there's many of the experiments that we're performing here that look at new technology, because that's what we're trying to do. We're trying to create new technology that's going to benefit the Earth.
Thank you, Thomas. We're now heading to Ireland for their two questions. Ireland, please go ahead.
Hello, Thomas. My name is Mary Gorey, and I'm a science teacher from St. Joseph's College in Borrisiley, County Tipperary. Our question is, how long does it take for the research, experiments, and new findings done on board the ISS to be used in technologies and medicine here on Earth?
It's a good question. It's I mean, it depends. For some of the experiments, for especially technology demonstration, it's very quick. At the end of the mission, you've proven that the technology was suitable for space or for some other applications on the ground. For some more complex human research, it takes longer, but that's not only true on board the ISS, it's true everywhere for every kind of scientific research. For example, human research, we need a lot of subjects, and there's only a limited number of people who fly to space every year. So, for example, the space headaches experiment from ESA looking at headaches and how to help prevent them needs 24 subjects, so that's a few years of data collection, data gathering, then analysis, and then only publishing and getting the results. So we're working on that. We're trying to make that cycle between the idea and the result as short as possible, but it's still going to be a few years because that's the nature of scientific research, unfortunately.
Hello, Thomas. My name is Alan Hobbins. I'm here with some of the boys from Clane Boys School. Our question is, how does your time in space help us to improve methods of caring for sick people here on the ground? Thanks.
So there's a whole section of the research we do on ISS, which is human research. So clearly, the goal here is to help improve what's existing on Earth and then make new discoveries. So we look at different things. We look at bone, we look at muscle loss because that's affecting us, and we apply these results to people suffering from those pathologies on the ground. We look at neurological research, how the brain of the astronaut gets rewired in a new environment, which is pretty much the only example of such a process in an adult human being. And what that does is when we come back on the ground, the scientists can study how we rewired our brains, and then it gives them a better, let's say, map of the brain, which is very, very poorly known. And then they can go see people who have had traffic accidents, bad motorcycle falls, and have brain traumas, brain injuries. And then now they know where to look. They know how to improve their condition. So that's two of the examples of what we do. But again, there's many of them.
Thank you, Thomas. And now we switch to Portugal for their two questions. Portugal, please go ahead.
Hi, Thomas. I'm Cesar from Escola Profissional Almada. How do you test for water and bacterial contamination on the ISS? Are these testing methods also used on Earth for other purposes?
How do we test for water? So we have a process, an existing process. We sampled our water system here on board the ISS, and we have a microbial detection kit. It's going to take 45 hours of incubation to test for coliform bacteria and for other microbial life. We have some different bags, different items that we test, different chemical substances that we test the water with. Again, on that Proxima mission, we're testing a new way of doing this, much faster. It's only going to be a few minutes to inject the water in a very tiny sample holder, and then you incubate and you get the result right away. And the idea is it's not only going to save us time here and make our life simpler on board the ISS, but it's also going to be used in countries where sometimes after a disaster, the access to clean water is problematic. So that's pretty much the way we do it.
We will now switch back to Romania for one question. Romania, go ahead.
Hello, Thomas. I'm Nicoleta from high school from Petrila. And my question is, when a natural disaster happens on Earth, can you see it from space? Is there a way that you or ESA can send a warning back to Earth?
Very often. So it's interesting to know that the ISS flies over 90% of the inhabited land in the world every 24 hours. So it's a very good platform for Earth observation, especially when it comes to land and and human activities. So very often we won't be the first ones to detect a natural disaster. It's going to be detected on the ground or by the satellites. But then what we do is we try to take imagery of it, and every day we have targets for us to simply take a picture of, and we're trying to get the best images we can of different floodings or volcanic eruptions, landslides, things like this. Not very nice, but we're trying to do our best. We also used to have a permanent imaging system on the ISS, but it's been retired. It's been retired recently, but so now it mostly comes down to us simply taking pictures the best we can and sending them down, and they're being used to assess the situation and to coordinate the support and the relief effort.
Thank you, Thomas. We will now head to Ireland for one question. Ireland, go ahead.
Hello, Thomas. My name is Gerard Donoghue. I'm a primary school teacher from Scolida, Corbally in Limerick. And our question for you is, what new technologies related to navigation are being used on the ISS and in space which can benefit us here on Earth?
So navigation is a big deal for us. It's a big deal on Earth as well. There's several different systems. One that we use all the time permanently on the ISS and people forget about it. It's called Vessel ID. So it helps tracking ships, ships at large at sea. Because there's very few ways for them to communicate between one another and to coordinate and to exchange information. There's no global monitoring system, so we're trying to provide this, and it can help ships avoid themselves, don't go on a collision course, or exchange information. So that's one navigation system that the ISS provides for ships on Earth, and that's being used every day. Now, as far as the navigation system we use, now we use a lot of relative GPS in space for visiting vehicles to approach and dock and fly information very precisely with the ISS. And that's one technology that hasn't been used too much on Earth, but is now being used for aircraft navigation as well, with initiatives like EGNOS and more precise approach patterns for aircrafts on the ground. So that's also one way that the ISS research and technology helps providing better conditions on Earth.
Thank you, Thomas. Now back to Portugal for one question. Portugal, please go ahead.
Hello, my name is Vitor Fernandes. I am a teacher at Escola Secundária de Forte Casa. I'm a computer science teacher, and I would like to ask, do you think it is possible to live in a completely self-sustainable environment in space? And are there any technologies from Earth that are helping this become a reality? Thank you.
So it's ISS is a very good example of not a closed environment, because we're still being supplied from the ground in terms of food, in terms of spare parts and water and oxygen, even though we try to minimize this amount as much as possible for obvious reasons, because it takes a lot of effort to bring those supplies on board the ISS. They have to be launched for the Earth. So we're trying to recycle as much as we can. We're trying to generate as less waste as we can, and to be self-sufficient as much as we can. If we want to go deeper into space, it's going to become a challenge, and the space agency have understood that, and they're working on it. In ESA, we have the MELISA project, which is attempting to create a completely closed environment, and it's going to produce its own water, its own food, and it's going to be completely closed from the rest of the world. And the idea is, if you can do this on Earth, and then you'll be able one day to do this in space. And there are some critical technologies that we're also testing here on the ISS, how to grow plants in space. There's a couple experiments, one running right now as we speak, that look at how to make that happen in space, so that when we go deeper into space for further mission, Mars and further, we have this capacity of growing our own food and not be dependent on supplies from Earth. We look at 3D printing, how to produce our own tools, and maybe one day we'll use the moon regolith to produce our own habitat, or our own modules, our own fuel on Mars. So those are all the projects that we're looking at, it seems futuristic, but it's going to happen if we want to go further, and we certainly do want to.
Thank you, Toma. Let's head back to Romania for one question. Romania, please go ahead.
My name is Octavian. I'm primary teacher. What do you think in one of the most significant discoveries or invention for society created from research carried out in space, and in particular on the ISS? Merci beaucoup.
So there's different ways that in which what we do benefits the Earth. There's of course a lot of technology that's being developed to fly in space and then applied on the ground. You think about solar panels, navigation, we've already mentioned it, lighter materials, better propulsion, things like this. And when you speak about research carried out on the ISS, we have a lot of research into alloys, and now if you have a smartphone that's lighter and stronger, it's most certainly using the results of what we do on the ISS. We look at medicine. Thanks to the robotics technology, now we can operate patients inside an MRI machine, which was not possible before. So some of the tumors that were unfortunately fatal before in the past are not anymore, thanks to ISS technology and research. We look at people's health. We look at understanding vision changes. It's going to help people with a bad vision on Earth. And there's just so many ways in which every day what we do, I try to think of how is that going to be useful to people, and very often I'm really pleased because I can see directly the link between what we do and how it's going to work on Earth, whether it be studying the immune system, working on a new vaccine, or working on material technology.
Thank you, Tama. We now head to Ireland for one question. Ireland, go ahead.
Hello, Thomas. My name is Mary McElhenney, and I'm a primary teacher in St. Bridget's School in Limerick City. And my question for you today relates to eyesight. We've heard that astronauts' eyesight can change while they're in space. And we're wondering if the research done in relation to this can have other applications, such as helping to prevent loss of sight in people on Earth. Thank you very much.
Yeah, we have actually a huge study that we're carrying out right now. I took part yesterday. I'm going to take part tomorrow as well. It's called Fluid Shift. It looks at vision changes related to human spaceflight in astronauts, because some of us experience a vision change during their spaceflight and sometimes after. So it's a huge deal for us. We're looking at it very closely. And the results so it's going to take a few years, like I said before, we really have precise results, but the results when we get them are going to apply to all the eye traumas in which the intracranial pressure is higher than it should be, and all that kind of eye trauma. So yeah, it will most certainly benefit people with these pathologies on Earth, and I'm hoping it's going to help people have a better eyesight.
Thank you very much for your time, Tama. Unfortunately, we have no more time for questions, so I'll give you a chance to say goodbye to Romania, Ireland, to Portugal, and to those following online.
Yes, it was a pleasure to be with all of you again across the whole of Europe from the International Space Station. And I'm particularly pleased that this event took place with teachers and students. It's actually studying hard at school that got me here, so I can only encourage the people, and especially the students and the kids, to follow their dreams and to believe in themselves and to study hard at school. School is not here to be in the way of anything. It's not here to bother you, to prevent you from doing what you like to do. It's here to help you. It's here to help you reach your goals. It's here to help you achieve your dreams. That's what worked for me, so I'm sure it can work for you.
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you to all participants from the European Space Agency. Station, we are now resuming operational audio communications.